All right, we're looking at section 5.4 for pre-calc. We're going to start today looking at three different types of identities: the double angle identity, power reducing, and half angle identities. There's a lot of stuff today, okay? It's all in nice colorful boxes. When you take the test for this half of the chapter, you will have a sheet similar to your green sheet. However, it will not have the top half on there. The stuff that we've already tested on, the things that you were expected to have memorized already, that's still not on there, okay? But for example, all of these identities that we have today, you will have in front of you. The key is, do you know how to use them, and do you know when to use them? Okay? So I just want to be very clear on that. I'm not saying you have to have them memorized, but you need to know what's available. If I ask you to do another trig proof and it uses one of these, you have to know it's there. You have to know, oh, there's a double angle or a half angle or a power in there that I can simplify down because I have an identity that works with that. Okay? So being aware of what's available is important. Memorizing the little nitty-gritty isn't as critical, but obviously the more you know, the easier the homework is. You don't have to constantly be looking things up. Okay, so we're going to start with double angle identities. The first one says the sine of a double angle is equivalent to 2 times the sine of the angle and the cosine of the angle. Okay? Be very clear when you're writing things today. This is different than this. Okay? If you're saying I want the sine of an angle squared, that little 2 needs to be a superscript, right? Raised. If you're saying I want the sine of a double angle, it needs to be in its regular lower position. And I know sometimes you guys write fast and you're going to get yourself confused. Was that a 2u or was that a square and then a u? Okay, so just be real careful of that. So we have one formula for the sine of a double angle. Notice for cosine of a double angle, we actually have 3 different versions, and it totally depends on what you know, what you're given, which one you should use. For example, if I'm trying to find the cosine of a double angle and I just know cosine of the angle, I'd use the middle one because it only needs a cosine. All right? If I only know the sine, I would just use the bottom one. If I know both a sine and a cosine, then I could use the top one. Okay? So base it on what pieces you're given or you can figure out. They are all going to work. They're all going to get you the same answer. It's just which one is the most useful at that time. Okay? So the cosine of a double angle is the cosine squared minus sine squared. Cosine squared plus sine squared is 1, but the minus version is the same as the cosine of a double angle. 2 cosine squared minus 1 and 1 minus 2 sine squared are also used for cosine of a double angle. And then for tangent of a double angle, we do have this version. So if you know the tangents of your angles, you could use that option. However, if you've already figured out the cosine and the sine of a double angle, then you can go to this version. All right, and I want you to add that in your notes packet, and I want you to add it on your green sheet. The tangent of a double angle can be found simply by taking the sine of the double angle divided by the cosine of the double angle. And a lot of times in your homework, it's going to say find the sine, cosine, and tangent of a double angle. So if you've already done the first 2, you can just use those 2 answers to find the third one. Okay. Our first example says to prove a double angle identity. This time we're proving sine of 2u is equivalent to 2 sine u cosine u. Okay? We're just going to prove that that one works. In our last chapter, half of the chapter, we had the sine of a sum. Remember that formula? The sine of a sum? Look in your green sheet if you can't remember it. The sine of 2u can be thought of as the sine of u plus u. Okay? 2u is the same as u plus u. And we had a formula for the sine of a sum. What was it? Okay, hold on one sec. We said it was the sine of the first times the cosine of the second. But in this case, they're both u's. Okay, so we're going to have sine u cosine u plus cosine of the first and then sine of the second. But again, for our purposes here, both of those are u's. So are these two pieces equivalent? Sine times cosine, cosine times sine, same thing. So we just get 2 sine u cosine u's, which is what we were trying to prove. Okay, so we started with the left side, the sine of 2u. We manipulated it until it turned into what we had on the right side. Okay, step by step. One step equals the next step. Just a different version. All right, we aren't going to take time to prove the other ones. Might have to in your homework. Just for fun. All right, next example. We are given that the cosine of x is negative 2/3 and the sine of x is positive. And they're asking us to find all three, the cosine, sine, and tangent of a double angle. So the first thing I want you to think about is what quadrant would we be in if the cosine of our angle is negative 2/3 and the sine of our angle is positive. Cosine's negative, sine is positive. Quadrant 2? Okay, so let's draw a picture over here, quadrant 2. This is going to be angle x. We know that the cosine is negative 2/3, which means adjacent over hypotenuse. Hypotenuse is never negative. So we'll make hypotenuse the 3 and the x, or adjacent side, would be the negative 2. Can we find the vertical side there, the y piece? Pythagorean Theorem? Okay, so negative 2 squared, I'll say plus y squared equals 3 squared. What are we going to get? So y is going to be either positive or negative root 5. But in this quadrant, it would be positive. Okay, so we'll put a root 5 there. And now based on that triangle, we really know sine, cosine, and tangent of the angle, right? They're asking us to find the sine, cosine, tangent of the double angle. So we'll start with sine. Never mind, we'll start with cosine. All right, cosine of 2x. What's the formula we have for that? Okay, we have a cosine squared minus sine squared as one option. Do we know both sine and cosine from our triangle? Okay, then we could use that one. All right, so it's going to be cosine squared of x minus sine squared of x. What's the cosine of x? Negative 2/3. And the sine? Square root of 5 over 3. Okay, can we square those both? Okay, squaring negative 2/3 gives us 4/9 minus 5/9, which gives us negative 1/9. Okay, so we've found the cosine of our double angle is negative 1/9. Okay, how about the sine of a double angle? What's our formula for that? Sine of a double angle. 2 sine cosine of the original. 2 sine x cosine x. All right. Plug in what we know. Sine of x was, thank you. Cosine was, okay. What does that simplify to be? Negative 4 root 5 over 9. Okay. Now, to find the tangent, since we already know sine and cosine, we can use those two answers. Okay. The tangent of a double angle is going to be sine of our double angle divided by the cosine of our double angle. We found sine to be negative 4 root 5 over 9, and we had cosine of a double angle being negative 1/9. What does that simplify down to? Yeah, 4 root 5. Okay, the 9's drop out, the negatives drop out. Yes? Questions on that first one? Nope. In this case, we knew sine and cosine, so we could have used any of them. What I said before was, let's say you only knew the cosine, then you'd want to use the one that just involves cosine. All right. Example 2. We'll come back to the properties. On your sheet, it's flip-flopped. Example 2 says to prove the identity that the cosine to the fourth minus the sine to the fourth is equal to the cosine of the double angle. Okay? So let's start with the more complicated side, the one with the fourths on it. Cosine to the fourth minus sine to the fourth. Can we factor that? Whoops. What'd you say? Cosine squared okay. So it's just a difference of squares pattern? We okay with that? Can we simplify either of those sets of parentheses? Which one? How are you going to simplify the one that has the minus? Oh, I see what you mean. You're going to factor it again? Okay, let's come back to that. The one on the right. Cosine squared plus sine squared is equal to 1. All right, we know that one. Yes, it's one of our Pythagorean identities. So this really simplifies down to just cosine squared theta minus sine squared. Yes? Because this is just equivalent to a 1. Okay. Now, it's asking us to prove if that is equivalent to the cosine of a double angle. So go to your cosine of a double angle rules. What is cosine squared minus sine squared? Cosine of 2 theta, right? So we're done. We've completed the proof. You had suggested earlier that we could simplify it by factoring it again. In this case, that doesn't help me at all because I was trying to prove that it was equivalent to a cosine of a double angle. I needed to get it into one of those formats. Okay, so just kind of know where it is you're trying to head. Okay, the power reducing identities is our next chunk. Notice that in all of them, we are starting with a trig function that is squared, and we are converting it into something that just involves cosines with a first power. Okay, so here we have squares, here we have first powers. That's why they're called power reducing. It takes something that has a higher power and breaks it down. Again, we've got sine squared over cosine squared. If we took and divided these two rules right here, it would simplify down to this one. Okay, tangent's just sine over cosine. So that's where that's coming from. Our first example says to rewrite cosine to the fourth of x in terms of a trig function with no power greater than 1. This is going to involve a lot of little nitty-gritty algebra. So if at any point you're confused on what I'm doing, make sure you ask. Okay, don't wait till the end and hope that it makes sense. All right, here we go. Cosine to the fourth. I have power reducing formulas for squares. So can we break cosine to the fourth into a cosine squared times a cosine squared? Okay. And now let's plug in what we have for our power reducing. Cosine squared is 1 plus cosine of a double angle divided by 2. Okay, so this is going to be equivalent to 1 plus the cosine of 2x divided by 2 for both of them. What is the denominator going to become? A 4? Can we pull that out front, factor it out front, and write it as 1/4? Like that? Okay, I'm just going to do that to move it out of the way so it's not quite so messy. What do we get now if we take the 1 plus cosine 2x times 1 plus cosine 2x? Agree, disagree? We're just foiling it out? Okay. Have we completed what they've asked us to do? Have we brought it down so that it's only first powers? No. We got some of it down. All right. This middle term here, the 2 cosine 2x is fine. But this piece right here has to be reduced again. And this is why the algebra comes in and gets messy, because you've got fractions within fractions. This is cosine squared of 2x. Okay, so we're going to write everything but what I've got in green. And we're going to replace what I've put in the green box with that power reducing formula. But take a look at the formula again. We went from a u here, and it became twice as big here, right? It got doubled when we reduced the power. The angle got doubled. So when we go and reduce this power of 2, this angle is going to get doubled. Does that make sense? So it's going to become 1 plus cosine of 4x over 2. I want you to take a minute and really think through what I just did there, because you're going to see that pop up a lot. When you take something that was being squared and try to reduce its power, in that formula, the angle has to be doubled. Okay? I put it where? Well, the 2 on the bottom is from our formula here. This 2 on the bottom. Okay, so what I'm saying is we're going from a u here to a 2u. If we're starting with a 2x, it becomes a 4x. If we had a 6x, it becomes 12x. Okay, it's going to get doubled when you plug it in there. Why what? Oh, when you're squaring a trig function, you're not squaring the angle, you're squaring the cosine sine tangent part of it. Okay? So it's kind of like saying, if I said the cosine squared of pi over 3, well, what's cosine of pi over 3? So I'd be squaring the 1/2. I'm not squaring the pi over 3. Does that make sense? Okay. All right, good questions. Let's simplify this. It's too messy. You think it looks beautiful, but it's too messy for me. We got to simplify it down. Messy can be beautiful, I agree, but not today. All right, so simplifying this. We have a 1/4 still out front. We have 1 plus 2 cosine of 2x plus what? What is all this mess? 1/2 plus 1/2 cosine 4x. I'm just dividing here. The 1 divided by 2 gives me the half, and the cosine 4x divided by 2 gives me half of cosine 4x. Okay, I'm just splitting these two parts apart. Okay.
Instead of making it 1/2 plus 1/2 cosine of 4x, could you just multiply by the fourth, make it an 8?
We're getting there. You're a step ahead of me. So hold that thought. Okay. Can we combine anything inside the parentheses? We have a 1 here, we have a 1/2. Can we make that 3/2? So I don't have quite as many terms? Okay, now, if we were to distribute the 1/4 into everything inside, we end up with 3/8 plus what? 2/4 or a half? 1/2 cosine of 2x plus 1/8 cosine 4x. And I'm okay with you stopping there if you want. But what you may see if you're checking answers, a lot of times they will try to break this back down and get everything to have a common denominator and pull it out front. So this 1/2, could we think of this as 4/8 instead? So if we factored a 1/8 out, we would just have the 3 plus 4 cosine 2x plus cosine 4x. Okay? So again, either of these answers would be okay with me. You'd get full points on a test. I just want you to understand that those are equivalent statements. So if you see my answer broken all the way down to here, that's why. Okay? Rather than having everything with a fraction under it, a lot of times they'll pull that fraction out front so the rest looks a little cleaner. All right. Let's try one more of those power reducing. We have sine squared of x times cosine squared of x. And they want us to break it down into a single power of cosine. So go back to your power reducing rules. What was the formula we had for the sine squared? Say it again. 1 minus cosine 2, sorry. 1 minus cosine of 2x divided by 2. And then for cosine squared, it's 1 plus cosine of 2x divided by 2. We good with that? Okay. What's your denominator going to be? A 4. Can I pull that out as a 1/4 in front? Okay, let's get rid of that part of it. What do I get if I multiply 1 minus cosine 2x and 1 plus cosine 2x? Agree, disagree? Okay. Have I completed what they've asked me to do? No, I still have a cosine squared. I can only have a cosine to the first. So again, I have to take this part here, this cosine squared part, and reduce it again. Okay? So the stuff I have boxed in black, sort of boxed, becomes what? Close. 1 plus cosine 4x over 2. Okay? Now, let's clean that up. We got everything down, so it's only first powers. We just need to clean it up. This black part here is 1/2 minus 1/2 cosine 4x. Yes? That minus sign applies to all of it? Okay. Well, what's 1/2 or 1 minus 1/2? Okay. So now I have 1/4 times 1/2 minus 1/2 cosine 4x. I can either distribute that 1/4 in, or I can factor a 1/2 out. Okay, if I factor the 1/2 out, what goes in front? Becomes a 1/8. And then what do I have inside? Okay. All right, moving on to our half angle identities. We have the sine of a half angle. And notice that if we are trying to find the sine or cosine or tangent, any of those, of the half angle, we are actually using the full angle here. Okay, so it's kind of like those power reducing ones where what you had in front gets doubled when it goes in. Okay, we have the half angle out here, it gets doubled and becomes the full angle inside. Okay, you will notice that sine and cosine ones have a little plus minus in front of them. I need you to add this statement right here to your notes. It got left out by mistake. You need to ask yourself, which quadrant does my half angle lie in? That is what's going to determine whether you need the positive or the negative sign. Okay? So take a minute and write that down. Which quadrant does your half angle lie in? That's going to determine that plus or minus, which one you should use. Okay? Now, once again, with the tangent, if you know the sine of your half angle and you know the cosine of your half angle, you can simply divide the two answers to get the tangent of the half angle. Okay, that's another option. All right, you're basically going to get what you have here if you divide these two. Okay, so first one, it says we want to find the exact value. So you're not pulling out a calculator at all. It says find the exact value of the sine of pi over 8 and the cosine of 7 pi over 8. Are those ones that are on our unit circle that we know coordinates for? No. But they're related to which one? They're half of which one? They're half of a pi over 4, right? Pi over 8 is half of pi over 4. And we know coordinates for those. Okay, so we can use our half angle ones to convert this. Before we get started, we're going to figure out which quadrant we're going to be in. If we're looking at pi over 8, it is in quadrant 1. And sine in quadrant 1 is positive. Okay. For 7 pi over 8, we would be in quadrant 7 pi over 8. 2, quadrant 2. And this time we're looking for cosine. Cosine in quadrant 2 is negative. Okay, so we know what kind of answers we should be getting out, all right? Let's go back to our formula. If we want the sine of pi over 8, we are going to think of that instead as the sine of half of pi over 4. Okay? We want the sine of half of pi over 4. Based on our sine of a half angle, we said we would have the square root of 1 minus the cosine of the full angle. So 1 minus cosine of pi over 4 divided by 2. And which sign did we say we needed in front of that? The positive one. Okay. Well, what is cosine of pi over 4? So let's replace that. 1 minus root 2 over 2 divided by a 2. Now, right now, that is all under a square root symbol. Okay? We want to clean that up a little bit. We've got too many fractions within fractions. Can we think of that 1 as 2 over 2? So we could write that as 2 minus root 2 over 2 all over a 2. That gets a little confusing because there's lots of 2's here. What happens if we take something, we divide by 2 here, and then we divide by another 2 there? No, they do not cancel. If you divide by a 2 and divide by another 2, you have really divided by 4. Be very careful when you think about things canceling. For those 2's to cancel, they would both have to be in a denominator position. This bottom piece right here would have had to be a 1/2 for those 2's to cancel. Does that make sense? So what this simplifies to be is 2 minus root 2 all over a 4 under a big square root. Okay? I divided by a 2 and I divided by another 2. So I really divided by 4. Can we take the square root of 4? All right. So the last step here would be to clean that up a little bit more and just say that square root of 4 is going to come out as a plain 2. Notice it is not underneath the square root symbol anymore. The top part still is, and you are not allowed to square root individual pieces in a sum or difference expression. Okay? So because of this minus sign between the 2 and the root 2, we can't split that apart and square root each part separately. So that's all we can do. Okay? All right. Let's go back and try the cosine of, what do we have, 7 pi over 8. So that would be the half of what? 7 pi over 8 is half of, you're making it too hard. 7 pi over 8 is half of 7 pi over 4. Yes, if I multiplied 1/2 to 7 pi over 4, I would get 7 pi over 8. Yes, no? Okay. So we need the cosine of half of that. We go back to our cosine of a half angle. We're going to use this version. But we said cosine has to be negative in the quadrant we're in. So we're going to have a minus sign in front. Your big square root, 1 plus cosine of the bigger angle, right? The 7 pi over 4. All divided by 2. We good? Okay, let's clean it up. What is the cosine of 7 pi over 4? Which quadrant is 7 pi over 4 in? Fourth quadrant, cosine is positive there. So we have a positive root 2 over 2. Okay. Cleaning this up the same way we did the last one. We're going to think of that 1 as 2 over 2. We have 2 plus root 2 over a 2 all over another 2. So we are dividing by 2, and then we're dividing by 2 again. That means we're really dividing by what? Dividing by 4. Okay? And then we can square root the 4 and pull that out from underneath the square root symbol as a plain 2. And the top part, the numerator, is going to stay inside. Okay? All right. We have one left. We need to find the tangent of a half angle. Tangent of x over 2. Now we're not given the specific angle, it's just a generic half angle. What they have told us is that the sine of our angle is negative 2/5, and the angle, not the half angle, but the regular angle, has to be between pi and 3 pi over 2. So what quadrant are they telling me it's in? We're in quadrant 3. So let's draw a triangle in quadrant 3. And we are told that the sine is negative 2/5. So opposite side would be negative 2 and hypotenuse would be 5. Can we figure out the missing side? Pythagorean Theorem says negative 2 squared plus our unknown, we'll call it x squared equals 5 squared. Okay. Now, in this quadrant, would my x value be negative or positive? It would be negative. So we actually want a negative square root of 21 there? Okay. So based on our triangle, we really know sine, cosine, and tangent, right? We've got ratios for all of those? Okay. So going back to your tangent of a half angle one, we have 3 options. We can use this top one, square plus or minus the square root of 1 plus cosine u over 1 plus sine u. We have 1 minus cosine u over sine u. We have sine u over 1 plus cosine u. We really could do any of them. Couple comments about what would be easiest. In your triangle, you had one piece that had a radical on it, right? Was that sine or cosine? That would involve cosine. So keep in mind that if you use this bottom one here, you're going to have a radical in the denominator and you're going to have to do some rationalizing. Okay? Which is fine. You can do that. We did it last hour. But it might be easier to pick one of the other options. Then you wouldn't have so much rationalizing to do. Okay? So I'm going to choose this one. I'm going to say the tangent of my half angle is 1 minus the cosine of the angle divided by the sine of the angle. Yes? Let's substitute in what we know. The cosine of my angle is, okay, and the sine of my angle was negative 2/5. They gave me that one. Okay. What happens when you subtract a negative? So this is really 1 plus root 21 over 5. Can we think of that as 5 over 5 plus root 21 over 5? What does that simplify down to? All over. Look at it carefully. What? We've got 5s here, right? We're dividing by 5. We're dividing by 5. Sorry. We're dividing by 5 here, and then that whole fraction is being divided by negative 2/5. Will your 5s that I circled drop out? Yes. Do you see the difference in this one versus the last one we just did? So this becomes 5 plus root 21 all over negative 2. Okay, again, some books might write that as negative 1/2 times 5 plus root 21. Same thing. Either answer's okay with me. Okay. All right, I'll make it bigger here for you. So that is your assignment for this weekend.